Hello, my name is Rejoice. I welcome you to Menalize TV, and today our lesson is going to be based on energy, work, and power. So when we talk about energy, energy is the capacity or the ability to do work. So now let's look at some types of energy. We have so many types of energy, but here we'll look at just a few of them. So the first one we have here is mechanical energy. When we talk about mechanical energy is the energy possessed by a body by a virtue of its state or motion. So under mechanical energy, we have potential energy and kinetic energy. Potential energy is the energy possessed by a body by the virtue of its state. And then kinetic energy is the energy possessed by a body by the virtue of its motion. So the difference between potential energy and kinetic energy here is that kinetic energy is the mechanical energy in motion, and then potential energy is mechanical energy at rest. So we have solar energy, nuclear energy, electrical energy, and then chemical energy. We have so many of them. So here the SI unit of energy is joules. So as I explained earlier, kinetic energy is the type of energy possessed by a body by a virtue of its motion. So the formula for kinetic energy is 1/2 mass times velocity squared. So let's look at how this formula came about. So we all know that force is equal to mass times acceleration. So F is equal to ma, where the F is force, m is mass, and then the a is acceleration. So from this equation, we can make acceleration the subject. So making acceleration the subject, we have F over m, which is force over mass. But we know that acceleration is velocity over time. So putting this equation into this equation, then we have v over t, which is acceleration, is equal to F over m. So making the force, which is F, the subject from this equation, we have force, which is F, is equal to mv over t. So from the equation of motion, the distance s is equal to, into brackets, u times v, all multiplied by the time t, all over 2. But we know that u is initial velocity, v is final velocity, t is time. But here the body was at rest, so the initial velocity here, which is u, is equal to 0. So we have the distance s to be equal to v times t all over 2. So whenever there is a change in kinetic energy of a body, an external work is done. So here we can say that the kinetic energy here is equal to the work done here. But we know that work done is equal to force times distance. And we know the force here is equal to mv over t. And the distance s here is equal to vt. So the work done, F times s, is equal to this force times this distance. So when we multiply the two of them, we have something like this. And here, this t will cancel this t here. So the kinetic energy here, which is equal to the work done, is 1/2 mass velocity squared. So this is how we came about this method or this formula. Kinetic energy is equal to 1/2 mass times velocity squared. So here potential energy is simply mechanical energy at rest. Mechanical energy is equal to kinetic energy plus potential energy. And we know that their SI unit is joules. So here the potential energy is equal to mechanical energy at rest. So we have a body of mass m, acceleration due to gravity g. So the weight of the body becomes mass times acceleration due to gravity. So the work done in raising a body from the height h is equal to force times distance. And here the distance is h, and then the force is equal to, the force here is equal to the weight, which is mass times acceleration due to gravity. So the potential energy here, which is equal to the work done, is equal to mass times acceleration due to gravity times height, and the SI unit is joules. So simply work is equal to force times distance in the direction of the force. So the distance must be in the direction of the force. So the SI unit of work is also joules. So let's take an example. A horse pulls a car with constant horizontal force of 500 newtons on a level ground at a uniform speed of 65 meters per second. If it takes 5 minutes to reach its destination, calculate I, the distance covered by the horse, II, the work done. So here the force is 500 newtons, the time is 5 minutes, which is equal to 300 seconds, and the speed is 65 meters per second. And first, they say we should find the distance covered by the horse. But we know that speed is equal to distance over time. Here, we have the time and we have the speed, but we don't have the distance. But speed So we know that speed is equal to distance over time. So making the distance here the subject, we have distance to be equal to speed times time. And the speed is 65, the time is 300. So 65 times 300 gives us 19,500 meters. So here our distance is 19,500 meters. Let's come to the second part, which is II. So they said we should find the work done, and we know that work done is equal to force times distance, and the force here is 500 newtons, and the distance that we calculated earlier was 19,500 meters. So our work done is 9,750,000 joules. So let's look at power. Power simply means the rate at which work is done. So power P is equal to work done over time. The SI unit of power is watts. Take an example. Calculate the power when the work done is 20 joules in a time of 2 seconds. But we know that our power is equal to work done over time. So P is equal to W. So we know that power is equal to work done over time, and our work done here is 20 joules and the time is 2 seconds. So our power here is 20 over 2, which is equal to 10 watts. So thank you very much for watching this video. Remember to subscribe Menalize TV for more updates. Thank you. Bye.